turn you up in my ears real quick.
Open Podcast. Hello and welcome to the Hackaday Podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 359, Flying Squids, Edible Passwords, and a CAD Automaton. This week in Hackaday News, well, it's last week in Hackaday News, but here it is again. Hackaday Europe is coming up in May. We have opened up the call for participation, so I'll throw the link in again. Get a talk in. It's going to be in Lecco, Italy, small town on the shores of Lake Como. Not super far from Milan or Bergamo, not very hard to get to. Already we've had people thinking about where they're going to fly in and which trains they're going to take. But yeah, can't wait to see you all there in a new venue.
That's a beautiful space too, right? Beautiful city.
It's a nice engineering university there as well, so it's not the wrong sort of scene either. But if you are still longing for an excuse to get up to Berlin, the weekend after is actually Open Source Hardware Association's Open Hardware Summit, and I think they were in the UK last year. This year they are in Berlin. So that's the weekend after Hackaday Europe. So if you are flying from overseas, you can make it a twofer, extend your vacation a little bit. If you're in Europe, well, it's just 2 weekend trips in a row. That's no worries either. Do you have any other news? I don't think so. Sold. So without further ado, let's do a What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
This is a new sound week. We'll be playing a brand new sound for Al to guess at and all of you. The previous What's That Sound was so easy. Everyone who wrote in got it correct. This week, I'm hoping for a stumper.
I'll have to go back and look. What was that? What was so easy?
It was The Hitchhiker's Guide to the Galaxy
Yes.
talking intro from the BBC's version of it. And yeah, I mostly put it in there because my wife reminded me of it, and I just really wanted people to remember this most awesome of A, radio programs, and B, I guess, TV series.
Leave it to me to miss the easy week.
Yeah. Well, Tom was like cackling in glee. Jenny, of course, heard it first run on BBC Radio. So.
Yeah, I was going to say, if Jenny didn't get it, I'd be totally surprised.
Yeah, 2 for 2 on the staff on that one, too.
All right, give me a second. I'll listen to it. I'm convinced it's something spinning.
Okay. What could that be? Because it's kind of rhythmic.
Oh, and I'm probably fooling myself, but I think I can hear the Doppler shift going back and forth over center. So I think it's rotating. I want to say it's some sort of windmill pumping water. I don't know. That's a terrible guess.
That's an awesome guess. I love it. It is so far off the mark. It's ridiculous. So congratulations to me. I picked a stumper this week.
Well, I got to say, stumping me is a pretty low bar. I think you'll get more good answers from other people.
I'm hoping someone gets it exactly. It's a sound that some of our listeners may have heard before on the show, and that's all I'm saying. I swear, zip it. So if you have an idea what the sound is, head on over to hackaday.com/podcast. For this week's show notes, scroll down to What's That Sound. You'll find a link. Put in your handle and your guess, and we'll figure out what it is next week. And if anyone gets it right, we will roll among the correct answers for a Hackaday Podcast T-shirt. Well, let's head off to the hacks. My first one this week comes from Oliver Pett. It's a long, so far 3-part video series about building a tremendously complex modern automata. Love complex automata, don't miss the archer. Apparently, archery automata are a tradition going back a few hundred years, but most of them are kind of cheating. That is to say, they don't draw a bow like a person would. They pick up an arrow from down below and, shoot it off their lap. Some of them, throw it with the hand instead of pulling it against the bow. Here, Oliver, who makes automata for a living, wanted to do it right. And so he went into the kind of physiokinematics of actual people doing archery and tried to mimic this with this automaton. And it is super complicated. Normally if you see those simple automata, they'll have like 3 or 4 different degrees of freedom. This one has 18 joints across the like arrow arm, bow arm, the head moves, stuff like that. Especially the bow arm, because it pulls the arrow out from a quiver on his back, flips it around, actually knocks it on the string, pulls it back, and then lets go of it. It's a lovely, lovely mechanism, but fairly complicated to like choreograph this movement. So the first video actually is kind of an overview of the project and is really neat to see. It talks about 18 joints, what kind of motion system he has. So he goes with cables, and does he go with cables where it pulls and has a spring to pull it back? No, not enough tension. So he ends up going with 2 cables per degree of freedom. So in the end, there's like 36 little Dacron wires in there pulling these things around. He points out, and this is kind of interesting, when you're running this many cables through the arm to like make the finger joint move or something, if there's friction in any of the places where the cables are on a common pulley, one part of the automaton moving can wiggle another part of it. And it's kind of the equivalent of like common mode noise in electronic circuits. And what's funny is his paired push-pull arrangement means that any disturbance on one side is a disturbance on the other. And it actually kind of nulls out the common mode noise in a mechanical sense. It's actually kind of a neat analogy. All of these cables then end up in kind of lever arm cam followers that then ride up and down on a bunch of wheels, and that pulls or releases the cable and makes the thing move. First he builds it, and then he's like, oh, now it's time to cut all of these cams and design the motion. And how do you cut 18 precise automaton cams in this day and age? With CAD CAM, of course. So he's got a 3D model of the thing, and he's got it, I think it's Rhino, and then he has a motion planning overlay in this that lets him basically move sliders around to position things where he wants it. And so he kind of sets up these poses. He records the poses and then translates them into displacements on this disc to push the little cams around. The video we linked here is video 3, and that's the step where he's talking about how he went from kind of motion planning to cutting the cams and getting that whole system calibrated. And it's a lot harder than you think, and it's super, super interesting. If you're into 3D modeling of mechanical systems or CAD CAM stuff or cutting stuff or robotic stuff, this is a good video for you to check out.
We always think of robotics as something modern and requiring computers and all, but it really is true that there was a lot of work, from even something like as simple as a cuckoo clock, but there was a lot of things that we've forgotten.
Right?
We did the article a while back on George Duvall, I'll put that in there, with the 1961 robot arm patent. It was just insane how that actually works if you go look into that. Or what was the other one? The Westinghouse robot Electro. I think we talked about him in 2019. His claim to fame was he could smoke, which of course in those days was,
important.
It was an okay thing in 1939 to say, oh, I have a smoking robot. Isn't that cool? I never understand it. I mean, I'm not that mechanical, as I'm fond of saying. When I see all these mechanical contrivances, to me, it's as ridiculous as the Rube Goldberg cartoons. Canary A gets hit by sunlight B, causing him to scare cat C or whatever. And it just, to me, it's like, that's just as likely as this other stuff, except the other stuff works. So I'm really amazed when you don't have a microcontroller, the number of things you can do to get those kind of behaviors is crazy, but I could not do them. And I have much respect to people who can do stuff like this.
Well, I thought this one was actually the one you could do. You always say that you're not like mechanically oriented, but you can cheat by using CAD software. And this is essentially what he's doing here.
Yeah, but you still got to visualize it, right?
Yeah. Yeah, but he's got a model. You can slide the joints around and be like, what are these positions? And then you just hit go and it tells you the path to cut on the cam. I thought that was actually really neat as a kind of an algorithmic approach to making automata. I thought that was really cool. I'm glad you brought up history because, again, like you said, these are ancient and there are super old automata that do things that are even fancier than this one. And the one that still blows my mind, I went back and looked at this article again 10 years ago. We wrote up the Maillardet automaton. Fran Blanche was working with it in conjunction with the museum where it lives and just goes through kind of talking through this video where she's investigating the writing motion. This thing has so many cams in it and is so elaborate, but it writes a beautiful cursive hand and it writes out a poem and then signs it. And actually, when they found this thing, they didn't know what it was. An engineer at the museum put it back together and then they started to figure out what it was doing. And then eventually they ran it, it writes out this poem and then it signs it at the bottom. It signs it, courtesy of the Maillardet machine. And that was how they knew what this was. And then they could start researching its history better because the machine itself signed its own name. Anyway, that video is astounding. Go check it out. It moves not just X and Y, but of course also Z. And it used to have a pen that opened and closed a valve depending on how hard you pressed it down. So it actually mimicked the kind of dark line, light line, human writing effect you get when you're writing with like a fountain pen. What? And again, these were cut without the use of a CNC machine and were designed without the use of CAD CAM software. So like 100 times more amazing in a way and from 200 years ago. But the person who did it, of course, didn't divulge how they did it. These things were all super trade secrets back then. And like only the Maillardet lab, atelier, whatever, knew how to do the design work for these things. And that is a completely lost art. And I can't even imagine how you do it. So I'm super stoked that Oliver documented his way of working with this because, again, that would be lost in the future? That's not cool.
I threw a couple of other links to bizarre mechanical contraptions, like the one that shows the live weather forecast. So there's so many. It was actually I had to censor myself because I could have put 20 more in. I'm always amazed, though, like those things are very complicated. And some of the best mechanical contraptions I've seen have been very simple, although they're not that, obviously not that elaborate. So like if you ever look at how the key lockout on an old teletype worked, where the keys had a wedge that wedged out ball bearings and the ball bearings got wedged to where you couldn't push another key down until that wedge got pulled out of the ball bearings. Very simple. I wouldn't have thought of it. I barely understood it when I saw it, much less be able to think of it off a blank page.
Stepper motor is the death of the cleverly cut cams or something.
Yeah.
But it's nice to see people doing it the kind of old school way. And again, what I thought was cool about this was the kind of new school meets old school approach, like design the poses and then have the computer do the work to make this into the trajectories you need to cut into the cams, and then have your CNC machine cut them out of aluminum. He's going through this thing and he's like iterating on them, and you can watch him. He's just like puts a sheet of aluminum in there, hits go, it cuts out a whole new set of cams. He plays with it. He does it again. It's kind of fun. Rapid prototyping meets automaton building meets computer modeling.
Yeah, that's a cool one. Well, my first pick this week is Peltier fridges have an early death. Peltier Power, which is probably one of the most aptly named YouTube channels I've seen, has a bunch of videos on Peltier effect modules. His premise, and I think it's right, although, I thought I knew a little bit about Peltier modules because I've used them, but I didn't know this. They show you the curve where it says, okay, you put more power in and it gets colder, which makes sense, and it kind of peaks out somewhere. But his premise is really they're only showing you the useful part of that curve, that it's actually a parabola. So as you put more power in, it starts getting less efficient, which kind of makes sense, right? Your heating loss is going to go up. He thinks that a lot of the commercial refrigerators and probably a lot of the homebrew projects as well, you'll crank it to get to a certain temperature and you say, okay, that worked. So now I want to get colder. So I'm going to crank it up some more, crank it up some more, crank it up some more. The problem is once you get to a certain level of cold, which there really isn't cold, there's just absence of heat, you don't need as much to maintain it, right? It's like inertia. It takes more power to get something moving than it does to keep it moving. So when you say, oh, it's cold and I want to maintain it or get a little colder, and you push it further up, you wind up on the wrong side of the parabola. So you're actually burning more power through it than you need to, which causes it to be very inefficient and causes it to burn out early. Because if you've ever had one of these, you use them for the summer, and then, next summer you need another one. He actually found some commercial refrigerator, and I don't think he's hawking it. I think he just something he bought that seems to have figured that out also. So it gets to a certain point. Once it gets cold, it actually reduces the power. And then if you try to get a little colder, it kind of rides back up the parabola instead of pushing over past the apex of the parabola. I don't know. I'm not the expert on Peltier effect stuff. I did a design with one years and years ago when they were very obscure. And I did talk to the guy back then who was like the know-it-all of Peltier. Maybe he knew this. I don't know. But it does seem like at least something that's not terribly obvious, and he has a really good video that's worth watching if you think you're ever going to use these for anything, so that you don't make the same mistake and then wind up burning a lot of power to keep your cool, if you will. If you've ever used these, they don't like PWM very well, and they also, as cold as they get on one side, is as hot as they get on the other side. So then you've got the problem of pumping all that heat away somehow, right? And you've got to have big heat sinks or fans or whatever it is that's going to take it away. So they're not quite as magic cold module as you would wish. There's a lot to think about when you do a practical design with these. But the math he had and the premise he had about a lot of them being misdesigned, I think, was right on.
Yeah, that's the weird thing about Peltier coolers, is that when you start running more current through them, they get hotter. And it just totally defeats the point. But I've never seen it analyzed so clearly as in this video. And I think that's actually really useful. I've always had in the back of my head, from reading Hackaday for quite a long time, since it started, actually, I've had in the back of my head kind of this list of sources of hacker tiers. And Peltier modules are always one of them. They never work as well as you want them to in the real world. You think you're going to get this much action out of it, and you always end up getting less. And I've never really seen it quantified why. And I think he's starting to do that here. And I think that's a lovely thing to see. Like he says, when you start getting to that point, you need to actually let off the juice rather than add more, because your resistive heating is pushing you in the wrong direction. And knowing that and being able to characterize that in your system, and then given smarts we've got in microcontrollers these days, I'm actually starting to wonder if Peltier coolers can, in the future, not be the source of hacker tiers that they used to be. Because solar power used to be one of those sources of hacker tiers in my mind. Back in the early 2000s, solar cells were hard to work with because they give you an open circuit voltage, and then they give you a short circuit current. And then kind of in between these zones, depends on the incident illumination and maximum power point tracking and all sorts of kind of complicated engineering details that these days we've basically solved. And there are chips out there, custom ICs out there, that'll do the hard work for you, and you can actually just put it in your design. So I think some part of tech progress has taken the hacker tiers away from building small solar projects, and I just love that. And I wonder if the same thing can happen to Peltier projects if we, stop for a minute, sit back, put on our engineering hats, and try to figure a way out.
Yeah, you may be right. I mean, that's the interesting thing is Peltier effect isn't new. What happened was when all you could do is do it with a couple of pieces of wire, it really worked badly, right? It was
Yeah.
You could measure a little bit of cooling, but it was all swamped out by the resistive heating. So it was really semiconductors that made that possible. So maybe, like you say, maybe we're going to be on a renaissance of Peltier effect modules. It was funny. It was in the 70s. I read about them in Popular Electronics, and I have this weird memory where I can read something and I'll see the cover of the magazine it was in my mind, and I'll see if it was on a left or right side page and about where it was in the magazine. So at the time, I was taking apart chips under a microscope for a large company, and if you wanted to cool a part, they were usually doing that for testing, and they had these fixtures that had a socket, and they ran some kind of refrigerant under them. That's fine if you don't have them under a microscope, but if you have them under a microscope, that was like trying to work in an earthquake, right? Because any little vibration. So that was where I said, well, what about a solid state heat pump? And everybody said, what's that? And I'm like, I don't know, but I read about it when I was a kid. So I went to the library, found that Popular Electronics, found it, started going around. At that time, they were mostly used in aerospace applications. And I wound up talking to a guy in New Mexico who was like the king of Peltier effect modules. And he helped me figure out what I needed to do to make that work. It was a successful project. But I mean, we didn't really care about the efficiency of it and really didn't care much about the lifetime of it. We just wanted cold chips that didn't shake. And so we wound up cooling those with a combination of fans and heat pipes, which was another exotic technology back in those days. So I do think there's a lot you can do with these. It's just a matter of, like you say, they're so non-ideal to work with that, you have to really think about what you're doing. They take a boatload of power and you've really got to manage the heat away from them or they just fry themselves.
Yeah, cooling down the hot end is surprisingly the difficult part. And I love that you mentioned in your write-up of this, by the way, the cloud chamber application, because Hackaday has seen a bunch of these kind of Peltier-powered cloud chambers, which have to get down to minus really cold. And you can't do that with one Peltier cooler. In fact, the kind of standard hacker approach these days is to stack them 2 or 3 deep. And so the one gives off its heat, and then that gives it off into another one that pumps it off into, a really big CPU fan and cooler arrangement, right? Like with the fins and the fan and that whole deal to actually shed the heat. And that, I think, is another way of getting around this kind of problem he has here, which is if you design the system so that the heat it needs to push out is too high, and that makes the Peltier cooler warm up. Another possible solution to this is to just stack them, right? And so this one does half the lifting, this one does half the lifting, and then big ass CPU cooler takes care of the rest on the other side.
Is that a brand name?
It is, yeah. It's actually my custom brand name. Elliot's big ass CPU coolers.
There you go.
Cheaper by the dozen. Well, next up from me is a story about fancy bike tech that maybe isn't as good as the old-fashioned way. Tristan Ridley, why chains are still better for bicycles than belts. This may or may not be the case for you, but Tristan is doing a lot of transcontinental heavy off-road backpacking riding. And, so he's like biking across Canada and down into the States and then down into Chile. Fairly serious bike riding, and you may not be pushing your bike as hard as he is. But because of this, he wanted to explore a whole bunch of new technologies and was for a long time a proponent of belt drives, where you basically replace the bike chain that we all know and love with a tooth belt, very similar to the timing belts you use on 3D printers or in any kind of small machinery, but custom made for bikes and with some, instead of a derailleur, with some clever tensioning arrangements. All in all, the belt is lighter than a chain. There's less friction. There should be less maintenance, although that ends up being one of the things that he ends up debugging here. They don't stretch. Actually, if the belt has carbon fiber in it, reinforcing it, it stretches less than a metal chain, believe it or not, over time. They're quiet. They have all of these proposed advantages, but what he finds is that if you put it through heavy off-road use, there are a couple disadvantages that end up creeping up that kill the whole system. And one of them is dust and sand gets in between the teeth and the cog and eventually ends up abrading it. And he says it makes this horrible squeaking noise and then eventually fails. And so if you're doing a lot of like desert, you're crossing Utah on a bike, that is where actually, ironically, you want a chain. Mud packs in the gear teeth and blocks it. And again, because the belt is super not stretchy, anything that jams its way in between the gear teeth and the belt makes it expand. And that can actually just lock the system up. And so he has to get off the bike and back it all out until he clears the mud out because it just stops it dead. And last, the carbon fiber cores are actually incredibly stiff and resistant to stretching, but also brittle. And he has one break because of the sand wear problem. He pulls out his spare, puts it on, and it breaks within an hour. And it turns out that the little carbon fibers inside the belt had fractured probably while he was storing it. So, over the course of the year in the back of his bike, it had been rattled around so much that they actually broke. And so this is a really neat look at what should be a really promising new technology. Like on paper, this is like the super engineering solution. But then when you take it to a particularly harsh environment, like off-roading and stuff, it ends up being an absolute dismal failure. And like a lot of the things that should be good, like the low maintenance, he points out you have to be always clearing it. You have to be washing it in water all the time to get the stuff out so it doesn't block the teeth up. Whereas with a roller chain, because there's a gap on either side of the sprocket, it just pushes the dirt out to either side every time it engages. I think we see this a lot where you think you have a better design and then it meets reality or it meets a particularly harsh version of reality. I think in this case, there's lack of spares. Like he mentions, try getting a belt wrench to like remove the rear gear thing. It's a totally bespoke object. Like you can't just go to a bike shop and try getting a new belt, even if your belt breaks. Like when a couple of the links in your bike chain go, you just pop them off and put some new ones in there, and easy to keep 10 links in your backpack and just pull it out when you need them. It repairs the chain. Boom, done. There are these trade-offs. The like super high-tech solution works better in a lot of situations until it doesn't, and then it's totally fragile.
Yeah, but I gotta applaud the idea that it's easy to just say, well, this is how everybody else does it, so I'll do that too, but then you don't innovate.
Yeah.
I think we've seen that a lot in the 3D printer space because, belts were very common there. And then a few people started experimenting with fishing line. And I think the fishing line must have not worked out very well because it kind of came and went. I'm not sure what the real reasons for that were. If you look like Delta 3D printers have not caught on to become dominant, right? So again, though, somebody's trying something different. And I think that's where innovation comes in. You just don't realize it because once it becomes the standard, you forget that it was an innovation. It's just, oh, that's what everybody does. So I think it's great to try stuff like that. We did see a friction drive BMX bike that I think used belts, but I think it's more of a motor drive. So maybe that's a little different. Although it makes me wonder because I think we have seen more than one e-bike that has belt drives. I'll put this link in, but I don't think it's the only one.
I think most of the electronic bikes have belt drives.
So somehow, like you said, maybe they're just not pushed as hard as what he's pushing it. So that might be part of it too.
They run with really small sprockets and you can encase the whole thing. And that would have solved his problem with the dirt here too, right? Like if it wasn't, built like a normal bike, but instead they'd found a way to put a chain guard essentially all around the thing so that it wouldn't get dirt in it. Maybe that would help. And I do think that's what the e-bikes do, because they want to keep you from getting your pant leg stuck in it.
Well, and then I can't find it, but there was the bike where you pedal, which turned a generator, and then that sent power to the motor and the hub. So all the transmission wasn't through a belt at all. It was just through again, in the spirit of saying, let's try other things. And I do think a lot of times trying some of these off the wall things, they may not be perfect for themselves, but sometimes they'll spur somebody else, and I mean, we all do that in meetings, right? We're talking about next year's badge or something. We're throwing out all kinds of crazy ideas, but every once in a while, one of them triggers something that's not as crazy, right? And I think so I really like to see projects like that where people are trying to do something.
And to be fair to Tristan, he's a big early adopter of a lot of crazy new bike tech. And like he uses a derailleur-less, self-contained all in the hub gear system that, he still likes because it doesn't get fouled like regular gears do. And other things like this. Like he's totally into testing out the new tech. He just finds out that this one doesn't work for him. And like you say, the e-bikes all run on belts these days. So maybe there is a configuration of it that'll work just fine. This is the way we make progress, by trying out the new stuff.
Okay, my next pick this week was control your smart home with Trek-inspired comm badge. And Spanner Spencer, who's obviously a Trek fan, as are many of us on the Hackaday staff, excepting Elliot, of course.
I don't hate it.
I know you don't hate it. You're not in the same league as a lot of the rest of us. What's your science fiction of choice, Elliot? What do you like?
What is my science fiction of choice? I really like Dune, actually.
No?
I came into that late in life, but the book is really astounding. That's really good.
Yeah, that is a great book. Anyway, back to Spanner Spencer. He wanted to make a comm badge like on Star Trek The Next Generation. And it was a nice hack job because he basically just took some stuff he had on hand, a M5 stick C+2, which happens to have a magnet on it, and some cheapo dollar store comm badge looking item, and had the magnet on it so that it sticks through the shirt. He's wasting a lot of it, but who cares, So just as a hack, I mean, it's a nice hack. It's nothing earth shattering because it's just kind of off the shelf stuff, and some, voice stuff's getting pretty easy to do now. Here's the thing though. If you ever notice, I always thought the hard part about making the Star Trek computers real would be the way they can just go up to them and say, analyze this. And it goes, oh, sure. I figured out, I know how to do that, even though you didn't tell me. And it turns out that's not turning out to be the hard part. The hard part is making, Alexa or Google or Siri not respond to you when you don't want them to, and yet still respond to you when you do want them to, which seems to always work in science fiction, right? You almost never see them go computer, and it goes, what? I think there's a computer over there, and it goes, what? Oh no, I'm just talking about computers. They did have some nice things in Star Trek in particular, but a lot of the other shows that have shown voice response where, you say computer and it kind of gives you a little beep that lets you know it's listening. We don't seem to have that in real life. It just doesn't seem to work nearly as well. And so I think it's interesting that he's got that. And one of his points is that even though on Star Trek they can say computer, in The Next Generation they do frequently just tap their badge. So maybe that's something that the real voice assistants should consider, right? If you had something on your smartwatch or something that you could just say, I'm going to tap my smartwatch and activate my home system and talk to it, but it knows I wanted to talk to it because I pressed the button on my wrist, or dare I say the clapper, maybe you clap twice and it knows to listen then, or something. But there's got to be some better way than how it works today. And I just thought it was interesting that he was kind of exploring that. I don't know that he's got an answer to it. He does pick up the taps on the badge because the little computer behind it has an accelerometer. And so, it's got the microphone, it's got the accelerometer, it's got the network connectivity. I mean, we truly are living in the future where you just happen to have something laying around that you can make a comm badge out of if you just have the shape of it. So I don't know. I don't know what the right answer is. I always thought the other thing hard that the Star Trek computers did, probably the smartest computers in the universe, are the ones that control the automatic doors, because they're smart enough to know if someone else is coming, or if you're fighting and you hit the door, it doesn't open. I still want to come up with the algorithm for how those doors actually work. I don't think you're ever going to figure that out. Maybe that's the contest, the Star Trek door contest, right? We need to run that one next year.
Yeah, I think you're right. I remember when the Alexas and stuff were new, and there was a big deal about the wake words. And I read even some research papers where they're doing serious testing, running the thing in a noisy background, trying to figure out how many times it false hears you. That's why they picked a funny name like Alexa for it, is because it's easiest to disambiguate from kind of normal things people are saying around them. At the same time, sounding friendly and like a person name. But they did things like they would put him in a noisy room with a movie playing and record how many times it activated the wake word while watching Die Hard, and things like this to try to pick the wake words so that it didn't false positive all the time. I don't know where that all lies now anymore. I mean, I was doing this reading 10, 15 years ago, so it's all way outdated now. The state of the art in wake words may be different, but I love the idea of just tapping the damn thing. That's so almost unambiguous, but then I'm like, oh, what happens if I hit something? Or what happens if I don't know. I'm trying to think of the movements I would make in my everyday that would false alarm this thing into thinking it needs to listen to me instead of, doing the communicator tap. It is funny. I agree with you. It's weird that the speech recognition, the voice recognition isn't the hard part. It's the when should I be listening and doing the voice recognition that's actually, up front is the tricky part. And then conditional on that, once you're supposed to be listening, you just interpret everything you hear, whether it's Die Hard or a person giving you commands. But knowing when it's being spoken to is surprisingly useful.
And tricky. Yeah. I mean, I think my wake word should be like a whistle and a glottal stop. I think that would work, right?
Oh, you think that, but wait till you're watching a John Woo movie, and that's exactly the shooting and the bullets ricocheting sound is exactly the same thing, and you activate it 100 times per movie.
I don't know when they did it, but Siri has become annoying lately. I don't know if it's just the one I I'm exposed to a lot or not, but when you say, "Hey Siri," it kind of goes, "Uh-huh." It's very understated. It goes, "Uh-huh."
Uh-huh.
And it just
Nice.
sounds like, yeah, like you're bothering me. What? I'm sure they were trying to say, well, you don't want to go like, yes, what can I do for you, master? Because it's just too
Yeah,
long
yeah.
and you get annoyed with it. I still like the Star Trek thing. You say computer, beep, and it's like, that's good. Beep, that's good. I got it, right?
We don't need to make it seem like it's human. It's not human.
Well, especially a snarky high human doesn't really do it for me. Right? Uh-huh.
What?
Yeah. What now? What now? What now, Elliot? Yeah. I know there's now a couple of my Alexa devices have inexplicably gotten AI put into them, and some of them haven't. I can't figure out what the difference is between the ones that have and the ones that haven't, but they do seem to do a better job of just being conversational. So I wonder if they're applying that to wake wording as well, because that's one of those things like a human could do this with 99.95% accuracy, right? You don't hear Elliot on a TV show and go, what? And start trying to talk to the movie. You know it's a movie and you just get it. So maybe the large language models will help us with that, where they can say, oh, yeah, you're not actually talking to me, but because I have context. Problem with that is then they got to listen to everything you say, and then that's another can of worms, right? So
Yeah, I mean, the beauty of a simple wake word is that you've got this one task, and then you can put the hard stuff, the computationally intensive and expensive computer time stuff after that, right? And so that it makes a nice filter that way. And if you're running it all the time, I bet the batteries get hot.
Oh, I'm happy I threw in a Star Trek topic this week, so yay.
The last up from me, a TV transmitter from an STM32 is a fantastic deep dive both into old school analog TV and into pushing the last bits of ability out of a microcontroller from Chris Slicka. What do you do when you buy an old black and white TV and you want to put your own images on it? But old TVs are meant to receive signals across the air, that is broadcast at a much higher frequency than the underlying signal. And he discovers this one doesn't have a video in, so he needs to make this up-converted signal. Of course, you could, at least back in the day, buy an RF converter box that you plug the composite signal into, and it then modulates that and transmits on channel 3 or channel 4 or whatever. But lacking one of those and wondering if it was possible to do it all in a microcontroller is what led to this absolutely lovely project. So the first trick here is to just see if you can even make this carrier frequency at all. And Chris takes the microcontroller in question. It's a dev board. It's a Nucleo, I guess it's a G431, and discovers that it has an inbuilt op amp with an analog switch and says, can I just switch between high and low fast enough to make the 48 megahertz carrier signal that he needs? And by overclocking and with a little bit of kind of reading the data sheet and pushing the microcontroller as far as it'll go, he is able to. And what's fun here is that he just connects this multiplexer to the low signal, the 0 volt, and to the 3.3 volt, and just runs it at exactly the right frequency. And lo and behold, he gets a black screen on the TV. And that's the sign that you've got it right. If you can overwhelm the snow and just get nothing, that's a proof that you've at least got the carrier part right. Now the question is, how do you get some composite signal in there to modulate over this? So instead of switching back and forth between 0 volts and 3 volts, he hooks up the microcontroller's pair of digital audio converters. It's got a couple DACs on it. And so he puts one DAC on the high end, one DAC on the low end, and this lets him kind of amplitude modulate this signal. So instead of switching between full range, he's switching between something in between, and he can do this analog control over that. This, of course, also ends up requiring a little bit of overclocking and a little bit of extra work. I think he has to be switching the DAC faster than it says it will on the datasheet, but it ends up doing so. Fantastic. In case you are following along at home, this is a one-chip solution. This is one microcontroller is able to actually switch its output fast enough between two different of its internal DACs to put out a properly modulated television signal. I've never seen that before. That's hella cool. But wait, there's more. He wants to throw audio over the top of this. And audio, while you might think it should be easier, is yet another signal that's offset by, he says, 5.5 megahertz and has a swing of plus or minus 75 kilohertz. So he has to find another timing source to do audio. Ends up stealing the clock that's meant for driving USB, I think. It's meant to phase lock into USB for that system. So he uses a second clock domain for the audio, gets them both running, sent off, and lo and behold, bad quality audio and legitimate TV, but like broadcast. This is the radio frequency equivalent of it. So it's a TV. What is it? It's a TV broadcasting station in a microcontroller, basically. And he's made a board for it that he hasn't proofed out yet, but you should absolutely go check out, called The Video Thing. Cheekily, he breaks out the analog stuff so you can put in your own composite video and it acts as an RF modulator for you. It looks like it's a really cool little Swiss Army knife for playing around with old analog TV signals. So if you've got a CRT that you don't know what to do with and it doesn't have video in, here's your cheat.
Well, I have to say, this was super impressive. I had to wonder, though, it's one of those things where, if you have to ask, was it practical, then you're in the wrong place, right? The Hackaday is not necessarily the place for practical stuff. Back in the old days, you would take a TV that didn't have video input and you would just wire into it and make a video input for it, right? And that was a very common thing to do in the early days of computers. But wow, to be able to have basically a TV station on a chip.
And it's just a regular microcontroller.
Yeah.
Like it's just a normal old microcontroller these days.
Right. You just take it out of the box, program it, and it's a TV transmitter. I will say, what struck me, this would be great for this project, especially if you could figure out the color, which he says he has not figured out yet. And I got to tell you, the fact that you can take a TV camera, point it at a panda with a red bow, and it looks okay on a black and white TV set, and it looks okay on a color TV set, is one of the miracles of modern technology, right? I mean, that is just brilliant. Yeah. And I've written about that before even. But I've also written about when we used to fix TVs, there was a very expensive instrument. I had one because I bought it used and it was still expensive, called a B&K Analyst. And I'll put that link in. And it was basically a little TV station with all the pieces broken out, right? So if you said, well, does this TV work? You could just, like this, you'd feed into the antenna and go, nope, I don't see the little test pattern. So you'd say, okay, well, let me see, but I am hearing audio because it's got some tone on it, right? So I know the audio's okay. So now let me take the video signal and inject it in here. Oh, now I've got it. So that means the problem's ahead of that, right? And or I don't have it, so it's somewhere behind that. And you could basically get all the signals you needed to feed into the TV to kind of do that sort of isolation. Beautiful device. It had a CRT, a photo multiplier tube, and a little test card that went in, and it essentially was a flying spot scanner. You could make one of those with this, right?
Yeah, exactly. Here it's just code, man.
Yeah, you would just need a couple of output leads and maybe some isolation if you wanted to stick it in a TV that might have a couple hundred volts in it. But, you really wouldn't need a whole lot to duplicate a B&K Analyst with what he's got here, except the color parts. And that would be easy to do even with another way. You could just generate color bars, right? So a 3.58 megahertz crystal and some, a couple of ICs, you could do that. So that would be the project I'd want to challenge somebody listening to make is, if you want to repair old TVs, I'm sure you could not get a B&K Analyst now for under 6 digits if it was working, but this could be made in a weekend and everybody could use it. So I want to see that. My next pick this week, the panoramic film camera made from 3D printed parts. Dennis Aminev apparently has a real thing for panoramic photography. And when I say he's got a real thing for panoramic photography, I'm not kidding. He is on his 5th version of a 3D printed panoramic camera. So essentially, he started out with like a pinhole camera, and then he took apart an SLR, figured out how all the pieces worked, made 3D printed equivalents of them. And, if you look at it, it looks like something you could buy, right? It doesn't in any way look like a homemade panoramic camera. It actually takes 35 millimeter film. Of course, normally that's 36 shots to a roll, but because of the way he's got the focal plane, you only get 19 shots to a roll with this camera. But it's got exposure counter. It's got the winder. It's got a lens mount. It's got a viewfinder. It's got a tripod point. It's amazing that you could make a camera that looks like this, does something interesting that would be hard to buy. Again, it's the practical thing, right? Why build a camera that you could just go buy? This would be hard to find today, I think. And he gets to have it his way, basically. So very cool. I don't know, maybe not everybody's into panoramic cameras, but I could see that you could do like 3D cameras like this as well, right? We had the article this week on the history of the Viewmaster, speaking of 3D, which I thought was fun. But, there's a lot of possibilities here. And as I'm always marveling almost every week is, we live in a time where you can build something that if you showed it to somebody, they'd say, oh, where'd you buy that? They're not going to say, oh, look at that aluminum box with the Dymo labels on it. I'm sure you didn't buy that at the store. I mean, kind of like the TV thing too, right? It's amazing. You just casually pick up a part and build a TV transmitter in software. Well, you can also design and print a commercial-looking camera. So how cool is that?
Earl Grey tea, hot.
Exactly. You just have to get the computer's attention first,
But what's funny about it is it's kind of the opposite, right? Like the Replicator was making, and what a lot of people thought about 3D printing back in the early RepRap days was that it would be doing kind of manufacturing for people and making the boring things in life. And instead, what's happened is 10 times awesomer. It's making the crazy stuff that people can't buy for love or money. Like this guy wants a super wide angle panoramic camera. So he 3D prints it. He designs it and 3D prints it himself. Like that's fantastic. And I think that's much more interesting than, oh, look, we're replacing drain covers with 3D printed drain covers. Yippee, right? Like that doesn't speak to me. But people who have crazy bespoke hardware desires and can scratch that itch now, that's fantastic. And it really is amazing that he's got, a light, tight functioning camera entirely 3D printed. Like you shouldn't undersell that part of it. He uses a bunch of hardware, like, of course he's got a brass insert for the tripod thing. I think the mount part is a metal part metal part pushed into the 3D plastic to fit the interchangeable lenses and stuff, the bayonet mount.
Yeah.
So, there's a lot of stuff you wouldn't 3D print, but that's not the point here. The point here is that he's got a camera he couldn't get otherwise.
If this were a movie, Elliot, when you said that about the drain covers, it would have cut to some guy in a room full of drain covers on the wall getting angry. Turning us off in a huff,
Yeah.
Because there's that guy. He's out there. I don't know where he is.
Yeah.
The drain cover guy is out there, and he's listening.
Yep.
Well, and I think we're going to see a lot more of this because, people like me, I don't care about any of this stuff. I want to build the printers and make the printers better. And as we've talked about before, it's getting where that's really hard to do because the printers are really good. And, the days when you could just spend 30 minutes on the weekend tinkering and say, oh, I improved my print quality is gone. But as it becomes more accessible and better quality, it's going to bring out more people who have those weird interests because like you say, I want my panoramic camera. Well, I can't get it. Well, I could print it. Oh, okay, maybe I should go buy a printer and I can do that now. It's not a weird thing. It's not a hard thing to do. So I think we're going to see a lot more custom car parts and, all these things that people are interested in and have trouble obtaining. They're now seeing that that's possible. And I think that's going to be a real game changer. It's probably sad for people like me, but I think it's going to be really exciting in general. So
the facilitation of kind of hardware building things creativity. Like I see people doing this kind of stuff. There was this kind of latent desire to be able to make, I'm looking at my desk right now. We have a dog poop bag roll holder thing that I printed that exactly fits our leash, right? Like, why would I make this? And the answer is because it's fun to make it, not because we can't buy one. I'm sure we could have bought one, and I'm sure we'd eventually find one that fits our stupid fat leash. But it was so much fun to make it. And I think that's something that a lot of people are also discovering is that it's just fun to design things that then you can use every day or become part of your world or use for your photography hobby. All right, my first quick hack, easily replaceable USB port spawned by EU laws. This is a really neat new component. It's a USB port that instead of being soldered down to the printed circuit board has little spring contacts and is meant to be screwed on. The idea is that if the USB port is a point of failure in device, it's nice to be able to swap that out easily. And this is proposed new legislation to make these sort of things be necessary so that when your device X breaks because the USB port is busted, you can just undo 2 screws, put in a new one, and screw it back down. That's a crazy win for kind of repairability. I think it probably will add a little bit of money to the bottom end, but I also just like to see these kind of crazy new components out there. The most effective thermal mass works like a sunburn is a bit of research and a horrible pun. Most is the molecular solar thermal process. And this is weird. In the old days, we had hot water heaters that would work by being basically black pipes that you ran water through and it would heat up by being in the sun. Fancier versions of that then used other kind of phase change materials like wax that would melt. And so it could store more energy in the melting. This is taking that yet one step further. These are proteins that kind of unfold when they get heated up in the sun and then want to refold back later. And so you can use that as an energy storage medium. It's super energy dense, but as of yet, they're only getting like 20 or 30 cycles out of it. So this is weird future technology, but I just like it because it's a funny way to store energy. Next up, theory to thing, random number generator uses camera noise. I love random number generators. This one's the classic. It's a camera with a piece of black tape over the lens. The trick here is that it's using one of those ESP32 cam modules that are like $6 with the camera and the ESP32 all included. So it's a little bit of code, a piece of black tape, and out of that you get cryptographically strong string of random numbers. The video goes through all the tests he runs on it, and it looks pretty legit. I have no reason to think it would be otherwise. And last up, another video from ElectroArc 240. This is a teardown of a compact Intel 3000 watt water-cooled computer power supply. And if you do the math and divide 3000 watts by the 12 volts, you end up getting 250 amps. This is a mean power supply, which is why it has to be water-cooled. There's a whole bunch of neat tech in here. This is an Intel reference design that he gets to take apart, and it's a long, long video, but it's full of neat insight into the design decisions and all of this. It's not crazy black magic. It actually ends up working like any other power supply. It's just designed more complicated and with more noise reduction and all sorts of stuff that has to be baked in to take care of the 250 amps. I had never seen a grounded flux band on inductors before watching this video. So if you don't know what that is, it's kind of somewhere around minute 20-ish.
My quick hacks today, Philip Giacalone as PCB Tracer. It's a web-based tool that allows you to take pictures of a PC board and then kind of annotate them and trace them and kind of build a net list. It's one of those things. You can do bookkeeping in a spreadsheet, but it sure is easier to use a bookkeeping program, right? Yeah, you could load your picture into GIMP and you could do all of this, but the fact that it knows what a VIA is and knows what a pad is and knows, those kind of things, it makes a big difference. I haven't played with it much, but it seems very useful. And there's an AI tie-in where if you've got an API key with one of the vendors, it's not a paid thing for him, but you might have to pay the AI company. It'll actually take the net list and try to draw a schematic from it. I don't know how useful that would be. But, it does gorgeous looking X-ray pictures. I think it's if you're ever going to reverse engineer something, that's a pretty useful thing. But I've thought even if you're going to repair something with a PC board in it, that could be useful if you've got to do serious work on it. My next pick was Sebsite. Sebsite mentions that, and I don't think I realized this, or if I did, I forgot it, that the printf itself, the little things you put in a printf, like a %S and %D and all that, because of all the weirdness to it, it's Turing complete. So you could write anything you want in a printf format statement. And it's a total horrible abuse of it, right? It's terrible, terrible. But to that end, he's got a higher level kind of assembly-like language you can write, and then it generates the printf format code for you that would actually make that work. Once again, useful? Perhaps not, but how cool. And last but not least, MicroGPT is a website that has a small LLM model that generates little random characters that follow certain patterns, and it shows you all of its internals graphically. So you can click on a block and see what it's doing and kind of understand what's going on, and it has a little tutorial that takes you through it all. So if you're really trying to understand more about what's going on in LLMs, and frankly, whatever you think about it, you probably should know more about it, even if it's just to complain about it better. This is a really interesting thing. Now, it's not a giant LLM like a ChatGPT or something. You can't ask it big questions, but you can train it on data, see how well it's doing, and it's got some very interesting ways to show you just how all that gets broken apart and the training works and everything else. It's really cool.
All right, well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I picked Tyler August's What One-Winged Squids Can Teach the Airship Renaissance. This is a wild write-up about blimps. And if you didn't think blimps were interesting before, you will now. It's just a fantastic piece. I actually picked it partly just because I really enjoyed reading it. It's great writing, but also because I'd never really thought hard about the blimps. First thing you should do is distinguish a blimp from a zeppelin. I wasn't thinking hard about this. There are a bunch of lighter than air airships that have frames made out of mostly aluminum, sometimes in the super old days wood. And these are zeppelins. The frame is rigid. Blimps are just blown up balloons, basically. It's a balloon with some motors on it and a gondola. And what's really neat about that is that makes them a lot simpler. So simpler, cheaper to build, lighter weight. You don't have to carry the frame up there. But it also gives them a couple extra bonuses, like they are flexible and they don't ice up in extreme weather conditions and a bunch of other things because there is no airframe there. It's just a balloon. And that's kind of fun. It also, of course, is their downfall, which he points out here. And I didn't think about this either. There's only so fast you can drive a blimp, because if you try pushing a balloon through the air, eventually it deforms and it loses its aerodynamic characteristics. So anyway, if you're thinking of the Goodyear blimp, that's probably the right thing here. A lot of these blimps were made during World War II and fast and on the cheap. And he points out that because they're smaller, because they don't have frames, because they're just cheaper in terms of materials, they were perfect for kind of rapid spin up during World War II. And then afterwards, a lot of them still existed. They didn't have any tragic accidents. When you think about Zeppelins, you're thinking about some of the more famous accidents with them, and the blimps basically didn't suffer so much. So there were a bunch of them left over, and that's why you have things like Goodyear, who bought up a bunch of surplus military blimps after the war and used them for advertising. So it's a neat look into the technology. The most amazing picture he has here is from a blimp that they had used to observe a nuclear bomb test, back in the day, up close, and it just completely melted. And there's this horrible photo of the blimp nose first into the ground. That's the wildest photograph I've ever seen. Anyway, if you don't know blimps and you want to learn something about them like I did, check this article out.
It's something romantic about that. You have the old film noir trope with the blimp tied off to the Empire State Building, which of course that blimp mooring was never practical, but it seemed like the future, right? I think technically they're all aerostats, right? I think a blimp, a Zeppelin, even a hot air balloon are all types of aerostats. But it's interesting how public perception can be moved by just a couple of things. So like the Hindenburg crash was mainly because they couldn't get helium because we had all the helium and we considered it a military commodity that we wouldn't sell to anybody. So if it had helium in it, it might not have happened. But there were other disasters that people didn't see so much, like the R101, which is UK. Well, people in the UK will know that one. The Akron, I think, was the Navy one, right? Whichever one we lost on that one. Just that scene of, the Hindenburg burning and it's a big disaster, that kind of killed that whole industry, I think, and people just didn't want it anymore. Every once in a while, I hear about somebody's going to bring that back, right? They're going to transport this across the country with it and all that. And it seems like nothing ever happens with that, and I'm not sure why. I've long been interested in the World War II applications because a couple of miles from my house, there is an abandoned U.S. Navy blimp base, which has these most beautiful giant concrete mooring structures just standing out there in the middle of nowhere, waiting for something to happen to them. It was interesting. I guess Galveston Bay was full of barrage blimps and things like that, and that's where they managed them out of them. Very little ever heard about that, but they apparently had them in other places as well. So it was a really good article, and I think the real question to me is so are we ever going to use it for anything other than advertising anymore? And I don't know. I don't know the answer. I keep waiting for somebody to do something with them, but I just don't know.
The downsides of anything that's lighter than air is that you can't carry super much weight with it because the volume has to increase to lift that extra weight, and that means you have to have extra covering on it. And I think it ends up being difficult. Plus, they can't go fast. So they can't lift much, they can't go fast. It kind of limits the missions you can run with them. But for like observing things from on high, which is kind of what the military application was, they were looking for like submarines and stuff. All sorts of atmospheric research stuff. If you think about it, the difference between a blimp and like some of these high altitude balloon projects that people put up is that a blimp has a motor on it and can kind of push itself in one direction against the flow of the wind, which we don't usually do with high altitude hacker balloons. But that would be a really cool project. I don't know if it's possible to steer one up in the air, but the difference between a blimp and a balloon is basically just, the shape of the envelope. And there's no reason you couldn't design like a hacker higher altitude balloon in a blimp shape so that you could steer it around a little bit. And that would be pretty cool.
Well, it's interesting that I've seen this several times. I mean, you're going to swear I made this up, but I didn't. There have been proposals to transport like natural gas and methane by blimp. So instead of having a pipeline running around, gas pipelines, you would just have a blimp. But what could go wrong is, I think, the tagline to that, right? That's what I'd be telling my investors. What could possibly go wrong? And so I don't think that's going to ever actually happen. I mean, they talk about it a lot, but I don't think that's going to really happen.
Yeah, I think there's a lot stacked against the blimp. I think you got to have the right mission for the flight, right? And I think that's basically observation, science, low power, slow, high altitude stuff.
Well, my pick this week was Christina Panos's Motorola's password pill was just one idea. In the, what could go wrong category again, right? This is near and dear to my heart simply because I hate passwords. I'm sure we all hate passwords, right? They just seem like they're just horrible. So you either do bad things that you shouldn't do, like use the same password for everything or write them down or something. What are you going to do, right? You don't want to just have it all wide open, so you got to do something. Apparently, at some point in the past, Motorola, and full disclosure, I worked for Motorola many, many years ago. They were owned by Google at the time this went on, which was long after I was gone. But they had a proposal that they were going to have a pill that you took. It had a small switch inside of it and a chip. And the stomach acids would turn it into a battery, basically. And you wind up sending out this ECG signal with, I guess, your body as the antenna. So you touch your phone and it goes, oh, I see this 18-bit signal coming out that, oh, I know that's Elliot, I'll unlock, right? There was a company called Proteus that apparently already had FDA clearance for a medical device that had ingestible sensors that used that technology. I guess it was safe to ingest up to 30 of these pills per day for the rest of your life. Now, I assume you didn't have to take 30 of them. I don't know not quite sure what the genesis of 30 was. So maybe you had to take your company pill so you could open your office door and your personal pill to unlock your phone. So maybe that was 2 a day or something like that. What a weird, strange story, right? So Christina, of course, not just being content with having a weird story, which would have been fun enough, she starts talking about other kinds of biometrics. And, there's a lot of problems with biometrics, not the least of which is they don't always work and they're easy to fake in some cases, or they're very difficult to implement. I remember years ago, they had the ad for some large bank. I can't remember which one. And even if I did, I probably wouldn't say, but it was like, one day, the only digit you'll need in your PIN is this one. And it shows some guy's index finger. And I'm thinking, well, that'll work until people figure out they can use a bolt cutter, cut your finger off and get into your ATM account, right? You say, oh no, because we're going to have liveliness checks and it's going to have a pulse and temperature and all that. That can all get faked pretty easily, right? So I don't know. I don't know what the answer is, but I will challenge everybody listening. Come up with something better than passwords, and I think the world would beat a path to your door. There were some other weird ones, apparently from that same conference, a temporary password tattoo. So I guess you've got a tattoo with a QR code looking thing on and it looks like it had wires and sensors and all sorts of other stuff in it. I mean, it's not like people haven't been trying to solve this. The real question is what's the right thing? And I don't think it's a temporary tattoo. And I certainly don't think it's taking 30 pills a day for the rest of my life to unlock my electronics. What do you think, Elliot? Do you use the same password for everything?
I love the idea of beeping out your password by a little radio signal generating pill you've ingested. That's like, that's such a Silicon Valley solution to a simple problem. It's like,
if you saw that in a science fiction movie, you would say that's totally unrealistic, right? What was that guy smoking when he wrote about that?
That's mental. Yeah, and so you won't be surprised. What killed this application was the cost, and in fact, what killed the Proteus application, where they were actually doing it for real medical use, so you could actually track. I thought that was maybe a cooler idea than the password one. I think the Motorola people were just like riffing off of this, and we're like, well, what else could we do with an ingestible pill that would turn you into an RFID tag? At least the application of has my patient taken their pill is kind of useful. Like, it'd be cool if a doctor could just go up to you and, put their cell phone on you and see that you've taken your meds today. That could be medically useful. It ended up being so outrageously expensive that Proteus Digital Health went bankrupt, of course. The idea that I'm so lazy, I don't want to memorize a password, so I'm going to eat $100,000 worth of pills annually is the most, I have no words. So yeah, that's why that didn't go anywhere. It wasn't the privacy concerns. It wasn't the creeping you out factor. It was the fact that you can just memorize a password and save yourself $100,000 a year.
Yeah, you have to wonder if there wouldn't be some high security, like if I were in charge of the nuclear codes or something, that you could put a RFID tag in my thumb or something and then two-factor that. So you say, okay, you got to have the thumb and you got to have the 6-digit PIN or something. I could see something like that. But just to say, I'm too lazy to unlock my phone with a 4-digit code, so I'll take, like you say, $100,000 worth of pills, and I wouldn't care if it was $5 worth of pills, right? I don't really want to swallow a bunch of electronics every day, and it just doesn't make sense.
Poop them out into the waste stream. No, it doesn't make any damn sense. I know a bunch of people who've injected themselves with those little RFID glass encoded capsules, and that's really cool. That lets you do a bunch of crazy things. And I don't know, do you guys do that in the States? Here in Europe, our dog is chipped like that.
Yeah, all the animals, if you get an animal from a shelter anymore, it's definitely chipped, and you can have them chipped even if you don't.
Yeah, so he's got a secret code, and apparently they're low frequency RFID. I really am half tempted to build. I have a reader for it. I could probably work something up with a microcontroller that would read the chip in my dog. Maybe we could do something cool with that. I don't know.
Put the sensors in your yard, and when you find somebody's left you a little present in the yard, you could identify who did it.
If it was the pills, yeah, I guess you could. In my mind, that's the competition for the automatic password unlocking thing, is you get one of these chips that are so cheap that they can mandate that every dog has to have one. It must be $5 $3. Like, who knows how much one of those little things costs? I think the cost is surgically implanting it in a safe way. But even that, they just have, you buy the off-the-shelf syringe and you go zoop. Vets do that day in, day out. It's not a big deal. That's the alternative.
According to the Google Oracle here, they cost vets $10 to $30 a piece. And then, of course, it'll be $25 to $100 to actually retail. I assume if they can sell them to the vets for as little as $10, there's probably $2 or $3 in them from the, to manufacture them.
Let's see. Google Oracle versus Elliot's cheap finding things on Alibaba. How much do we get for one of these? I'm getting RFID animal tracking chip for 70 cents in bulk.
There you go.
From Alibaba.
Perfect.
Injectable with syringe for 35 cents. What? It comes in a little plastic syringe. How many? Minimum order quantity 100.
Yeah.
There we go, dude. $29. I can ship everybody I know.
I'm sure they turn around and sell that along with the infrastructure to the vet for $10, right? That's the point.
Yeah, that doesn't surprise me. Yeah, I'm not eating pills with my passwords. The nice thing about the password pill, though, I guess, is that you can change it, right? Like, you change it every day. And people never rotate their passwords often enough. So if you just had like one of those little old person Monday, Tuesday, Wednesday pill things, right? You'd have a different password every day automatically. You'd have to preload that into the counterparty website or whatever it is you're logging into. But that's totally doable. You could probably do a pseudo-random number sequence on it. It would be like one-time passwords only in pill format. That's a lot better than getting chipped, because if you get chipped, somebody can just come up and read your RFID tag and then impersonate you later on. Whereas this one, you'd have a different pill every day. It's the security model, man.
I'd be afraid that people say, I called you, and why didn't you answer? You say, well, I can't get to my phone because I've already been to the bathroom today, right? So,
dude, like, I don't even remember to charge my phone. What's the chances that I'll remember to take my damn password pill? Please. That brings us to the end of another Hackaday podcast. Thanks very much for listening. To follow the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And until next week,
keep those hacks coming.
And then upload a file. Then let's get the show on the road. Whew. I think we're there. Analogy? Tristan Ridley. We'll go Ridley? 1D. Let's see what happens. I thought it was a failed idea. Was it Mickey Mouse Show?
I must have known this at one time. I don't know.